Hello everybody, and we're going to give a short demo of using Jupyter in Open On Demand to do data analytics. So first, I have to go to od.vrc.berkeley.edu, where I've obviously been before, ask for my username and password. And the password consists of a PIN that I chose when I set up my account and a one-time password that is being given by Google Analytics after I've registered. So when you set up the account, you have to do both those things. Set up a download Google Authenticator, registered with Savio, and uh, choose a password, and then choose a PIN, and then your password is PIN plus the one-time password that Google is generating for that site. So now we're logged in, and now what I want to do is go to interactive apps, and I want to choose a Jupyter server. And Jupyter Notebook version 3.7, that's fine, OOD Jupyter, and I want to launch this. This will take a few minutes. The data analytics example we're going to give is fairly short and simple. It doesn't require the use really of Savio resources. It could have just as easily been done on the Berkeley Data Hub. We're doing it on this to show you how to use this in Open On Demand. So it's starting. Once this process finishes, we'll be able to log into a shared node. Let's connect to Jupyter. And we're now connected to a Jupyter server. Now, what I'm going to do actually is I prefer the lab interface. So I'm going to go to the URL here. And before it says tree, I'm going to type in lab. And this is going to give me a Jupyter lab interface with the desktop, which is firing up right now. And now, as you can see, I actually have, typically when you log in, you won't see this. I was on this before. What you'll see is a desktop that looks like this, which gives you the notebooks you can fire up and other applications. And as you can see, I remembered what I did before. I had a terminal going, and I will again just to take a look at this. Now, in order to use this, I downloaded a CICE extent data set from Kaggle, and I'm now going to upload that to Jupyter to my directory here in Jupyter on Savio. And this, by the way, is my entire directory on Savio. So here comes the CICE dataset. I want to upload that. And now I've got it as a CSV file. So first, let's take a look at it in the double click takes it into the built-in viewer. And this is nice, but it doesn't show me actually everything. And because data downloaded from the web needs to be cleansed, I will typically want to take a look at it in an editor. I can use the built-in text editor here, open with the editor, for example. But also, this is a fully featured Unix machine, and so I have the VI editor available, and I'm going to use that. And when I do, I see that there are a couple of things that are wrong here. First of all, I've got all these spaces, and that's going to screw things up. So what I want to do is get rid of all the spaces in line 1 using a standard Unix VI command line substitution, substitute all the strings of blanks for nothing, and put it in /G at the end, say do it globally. I also have, since I uploaded this from PC, a bunch of Windows characters at the end, that .m, so let's get rid of those. And now we're done. And so now we have the sea ice data set. And if we take a look at this, what we have here is the year, month, the date, the extent of the sea ice, missing, which we don't really need. I could actually delete that. And the hemisphere, which is going to be either north or south. So let's quit out of that. So now we have the data set nicely cleansed. Now what we want to do is start to analyze it. And the first thing, and so what we're going to do is go to the launcher here and fire up a Python Jupyter Notebook, which we'll do in Python 3.7 or 3.9.12. So you can see we have different versions that we can use here, and also different libraries loaded. Like these are mostly for TensorFlow. So I'll fire up a 3.9.12 notebook, which has the name Untitled. And the first thing I want to do is to import the libraries that I'm going to need. I hit Shift Enter to execute, and it all executed, didn't complain. So all of those libraries are pre-installed. Now, one of the libraries we installed was Pandas, which is the Python ubiquitous data analytics library. One of the things Pandas can do for us is just read a CSV file and turn it into a Pandas table, or data frame as it's known. So we're just going to use that. Just tell Pandas to read the cice.csv file without an index column, and put that into the CICE data frame. And now let's take a look at what we've got. And here we can see we've now read it in. There are 26,000 rows. And we have the year, month, day, the extent of the ice, missing, which again we'll never going to use, and hemisphere. Now we want to make sure that that we actually have the right column names. So let's just take a look and make sure we've read those. We can do that by taking a look at the columns. And that looks right. No spaces, nothing strange there. And we also want to make sure that it read the types appropriately. We want year, month, and day to be integers, extent to be a float, missing to be a float, and we want hemisphere to be a string, or object as it's called. So let's take a look at the D types. Pardon me. That's CICE data.d types. And here we have the year, month, and day are all integers, extent, missing, or floats, and hemispheres, object, which is a string. That's nice. Now, frankly, this doesn't do me a lot of good for linearly increasing things because, of course, we're not terribly interested in days, but we really want to know that 1979 month 1 1979 is later than 1979 days. So the easy way to do that is to arrange the months in linear order. And we notice that the earliest year we've got is 1978. I should verify that, but for a short demo, I won't. And so now what I want to do is just say, okay, the month from start, we're going to call month 1 of 1978 month 1, and then after that, 2, 3, 4, 5, and 6. Define a little function to do that. And now I'm going to do month from start 1, 1979 is 13 indeed, and month from start 1 of 1978 is one as it should be, and I'll do one more. month from start of 6/1980. So 1 of 1980 should be 25. 6 of 1980 should be 30. So let's do that. And indeed it is 30. So that's good. So now we've got that one correct. Now what we want to do is we want to put a new column with this month number in the table. And what we want to do first of all is compute it for each row in the pandas data set. So now what I'm going to do is just say, hey, apply this function to the year and month columns of a row. So take a row, take its month and year columns, and then apply month from start to it. And now what we want to do is say to the pandas is create a new column in the pandas data frame, which is just that result for every row. So we're going to say that the month num column of CI's data is the application of the month from row function uh, to each row. Axis equal 1 means apply it to the row. So now we're going to go ahead and do that. Look at CI's data. And indeed, now we have this month number here, which is increasing. Month 10, the first month we've got is month of 1978. Now, the next thing we want to do is to say, look, what we're not really interested in daily extents. What we'd like to do is take a look at the extent by each month. We like the max, min, and mean, max, min, and mean for each month. So we're going to create a class. And what this class is going to do is it's going to take all of the rows for given a particular month and a particular hemisphere. So say month number 12 in the northern hemisphere, and just create a new data frame as that. So that's a subset of the one we've got. And then what I'm going to do is take the extent series for that. So just pull out this column. And then what we're going to do is take is also pull out the year and month. They're all the same, so we just pull it from the first entry. Take the month num from what's passed in, and the hemisphere from what's passed in here. So now we've got the extent for a given month, given year, and it's going to sit in this month aggregator. It can take the average of the series, the max of the series, and the min of the series, the min max. And now what it's going to do is it will also define a function row, which will return year, month, the month number, the hemisphere, and the min, max, and average for that particular month. Let's go ahead and define that class. And now what we want to do is we want to apply it to the entire data set. So we're going to create a cell to do that. And now what we're going to do is find all the all the month numbers. We're going to find all the hemispheres. We're going to put them into a set. Just get the month, get the month and the hemisphere for each one, and then turn that into a set. So we'll get rid of duplicates. So we get just all the unique pairs of month number and hemisphere. And then what we're going to do is put into the dictionary for each month the aggregator that we just created for that month and hemisphere. So it's going to pull in all that data. And then all we're going to do is say, hey, give us the rows. So now that we've done that, once it finishes computing, let's take a look at the first few rows. Let's do the first 5 rows. And as you can see, it's got, in fact, year, month number, hemisphere, min, max, and mean. Now notice that this is not, that we really like to have these in ascending order. We can do that fairly easily. Just say rows, tell rows to sort itself, and we give it a key function. Sort it by the, we want to sort it by the third entry, which is x2. Now that we've done that, let's take a look at the first few rows again. In fact, here we are. They're in, well, sorry, the last all but five. That's not what I wanted. It's not a manageable number to look at. That's more like it. So as you can see, we've got the first 4 or 5 months. And now what we want to do is let's just put this into a new data frame so we can do some analytics on it. So um, what we're going to do is do monthly data is equal. Tell Pandas to create a new data frame. The data are the rows, and now we need to give it some column names. Here, month num, hemisphere, uh, and that's mean. Typo, get rid of that. And so now we have monthly data. And because we've got that, now we can take, say, a slice. So suppose we want to say, see what the sea ice extent was for every year in January. We can say monthly data, and we want to select the rows where month is 1, and the, so we're going to take just every year, but the month is 1, the hemisphere is north, and we'll ask for that. And as you can see, here we can see the min went from 14.9 to 13.0 the 40-year data, or to 12. So we can see if we plotted this, and there are a number of tools which I'm not going to show in this short demo, which we can use for plotting this. We will be able to see this that the sea ice has been declining. Well, that said, I should rename this. Uh, I should rename this to something meaningful. CIS.ipm.ymb. Notice it changes there too. Now, the other thing is that we're occupying a node on Savio, and when we're done, we're done. So what we should do is say, okay, we're done with it. Let's uh, delete. Let's delete this session. Yes, confirm, because we want to give up the resources so other people can use them. And with that, thanks very much for your time.